So we've got student speeches at graduation. Lengths are normally distributed. This is a normal distribution question. Mean of 122 and a standard deviation of 24. So if we look at that, it's always nice to draw it. And let's see, we've got here a normal distribution. The mean is at 122. Standard deviation, so that's the point of inflection here and here, pretty much. Not my best ever diagram. That's 24, and that's 24. Find the probability of students selected random speeches over 2 minutes long. Well, actually, we look at 2 minutes here. 2 minutes is there at 120 seconds, and we're trying to find this probability here. So let's first of all say that the speech length, so length is distributed normally with a mean of 122 and a standard deviation of 24. So that's 24 squared because we have to put the variance in there. That's A. I makes a speech over 2 minutes long as the probability that L is greater than 2 minutes. Or same as greater than equal to, because it's continuous, it makes no difference. So now we have to find the probabilities over that. Put in your calculator as a normal CDF. We only ever use CDF, or inverse normal for normal. We never use PDF. So that's 0.533206.8, etc. That's approximately equal to 0.533. And the speech is under 1 minute. It's the same again. So now we're under 60 seconds. So 60 seconds is here. We're trying to find this probability here. So probability that L is less than, as we should say, 120 here to make it consistent with the units we said there. And this is less than 60 is going to be 0.004895, etc., which is approximately equal to 0.0489. That's 3 significant figures. Find the speech length that 25% of students will exceed. So again, we've got our normal distribution here. We know our mean is 122, and we know that 25% of students here are going to go more than whatever this length is here. So now we need to do an inverse normal to go backwards on this. So the way I can write this is saying the probability that L is greater than, let's put little l, is equal to 0.25. If you're on the TI-84, you can do that calculation. It'll let you go right. If not, on the TI Inspire, you need to be looking for this one. The total area is 1, so we do 0.75. So put that as an inverse normal with 75%, and we should get 138.1877 ... which is approximately equal to 138 seconds, or 2 minutes. 2 minutes, 18 seconds. And below which will be 10% of the students. So that's an inverse normal again. Probability that L is less than L2 is 0.1, because we're now trying to get 0.1 over here, which is inverse normal 91.24276, which is approximately equal to 91.2 seconds, or 1 minute 31.2 seconds. Now, find a probability in a house of 10 students. So we've got the houses speaking, and will speak together. Exactly 5 makes a speech over 2 minutes long. Remember, so they're either over 2 minutes long or not over 2 minutes long. This is now, we've got a long speech is distributed binomially, where we've got 10 students to check, and the probability of being over 2 minutes, I've got 2 minutes is this probability we calculated up here, and I should use the non-rounded version. Can't use rounded versions in there, so 0.532206, etc. I want the probability that LS equals 5. So we have exactly 5 of them doing that. That's a binomial PDF. So that gives me 0.240714, etc., which is approximately equal to 0.241. So 3 significant figures. And then at least five of them. So now part D is the same thing again. It's the probability that LS is greater than or equal to 5. That's at least 5 of them. So a CDF between 5 and 10, or do 0 to 4 and subtract it from 1, because you want to get, in effect, we've got now a graph here where we've got 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 students. And we've got some graph here that looks like this. And we want to do everything that's greater than or equal to 5. So you can either find these ones and subtract them to 1 to get these ones, or you can go straight to these if you're on the Inspire. CDF between 5 and 10 is 0.701598, etc., which is approximately equal to 0.702, to 3 significant figures. The student's still talking after 5 minutes. 5 of the probability they'll still be talking after a further minute. So now let's go back. This is actually going back to a normal distribution. And the mean is just over 2 minutes. So we're finding them. This is our 2 minutes, 120 seconds. We're doing this one. And then we want to find out, still talking a minute later on, that's 180. Is this bit here. And that's the probability that the length is greater than 180, given that they've already spoken for 120 seconds. So if they've spoken for 2 minutes, what's the probability they'll carry on for 3? This is, they've done this given that they've already done 2 minutes. It's a given that question, a conditional probability. So now we have to work out, this one is the probability of the intersection of the two. It's greater than 180, intersecting greater than 120, over the probability that its L is greater than 120. That's using the formula booklet with probability of A given B is probability of A intersect B over probability of B. So now we have to work out the probability of being over 180 to get this bit. And if we look at this, the intersection of these is where this bit is true and this bit is true, which is actually where the intersect is actually where it's greater than 180. So it's actually the probability where L is greater than 180 over the probability it's greater than 120. So actually it's easy. We don't have to work out this intersection. This intersection of these two bits is just this bigger bit, this smaller bit here. So we can do that straight away. So on the calculator, you need to do a CDF of, so probability that L is greater than 180, CDF normal distribution is 0.00783,167, etc. And we need to do the, so this one is 0.007831, etc. over the probability of being over 2 minutes, which we've got back here, was 0.5332068. When we do that calculation, do 1 over the other as a fraction comes to 0.014687, etc., which is approximately equal to 0.0147. Conditional probability is done. Watch out for those in case they turn up. That started here, didn't it? Part E, you should label it.